Okay, so welcome back to another video. So in today's video we have the integral from 0 to 1 of x multiplied by the square root of x multiplied by the cube root of x multiplied by the fourth root of x multiplied by the fifth root of x, and so on and so forth on dx. So you can clearly see that this is a nested radicals of with our base x, and we're being asked to evaluate this integral. So I wouldn't let this integrand like intimidate you, and I say that because we can actually rewrite this in a way where it's eventually later it will be easier to do the actual integration. So let's jump right in and you'll see why. So focusing on this integrand, so I'll just rewrite the same thing as before as we're given. Okay, so the same thing as given as the rewritten integrand. We can actually rewrite this as the following. So we can actually convert this into our base with the exponents. So our exponents in this case with radicals is in fractions. So this means this is equivalent to x to the power 1, that's coming from here, then multiplied by x to the power this square root, so 1/2, okay, and then multiply with x to the power so it's a cube root 1/3, and then associate with the square root, so that means this is times 1/2, then multiply that with x with the power 1/4, then 1/3, then 1/2, and then you see the process still goes on. Okay, that's nice, but you'll also see that with the exponents listed as it's nested, it actually forms a factorial. So in other words, I can write this the following. So x times x to the power 1/2. Then here comes the factorial. So 1/3 times 1/2. So that's basically just 1 divided by 3 factorial. Multiply with x with starting with 4. So then we have 1/4 factorial. And I'll expand this a little further since we have 5. So that's the sequence is the same. So it's 1 divided by 5 factorial, and then so on and so forth. Okay, not too bad. Now we can actually use our rules of exponents, and because they share the same base, we can actually just add the exponents together. So this means I have x to the power 1 plus 1/2 plus 1/3 factorial, then plus 1/4 factorial plus 1/5 factorial, and then the sum continues from there. Okay, so now what? So let's actually recall let's actually use the function e to the power x and use its Maclaurin series. So let's see, Maclaurin series of e to the power x. Okay, so this means e to the power x is rewritten as the following. So this is the infinite sum starting with our index n is equal to 0 to infinity of x to the power n divided by n factorial, such that it's for all real numbers x. Okay, so now let's actually plug x equals 1. So plug x equals 1, so that means I get e is equal to, let's see, n equals 0, and then this will be just 1 divided by n factorial. And so when I expand this out, I'll get, let's see, we start with 0, so this is 1, and n equals 1, so plus 1, then plus 1/2 factorial, which that's the same thing as just 1/2, and then plus 1/3 factorial, plus 1/4 factorial, and then continues on, so forth, so forth. Okay, now what I can do is I can actually just subtract our term 1 to both sides. So I get e minus 1 is equal to 1 plus 1/2 factorial plus 1/3 factorial plus 1/4 factorial, and then so on and so forth. Okay, with this I can actually just substitute that back to our power x. So therefore now I'll just rewrite x, let's see, 1 plus, just rewriting the same thing we had before, then 1 over 3 factorial plus 1 over 4 factorial. Okay, that's simply just equal to x to the power e minus 1, simply because we defined this from the Maclaurin series, so we actually do that substitution. So now, integrating this is easy from here. So then we have that the integral from 0 to 1 of x to the power, or x multiplied by the square root of x multiplied by the cube root of x multiplied by the fourth root of x multiplied by the fifth root of x, and then so on and so forth, dx. Simply rewriting this, we have that it's the integral from 0 to 1 of x to the power e minus 1 dx. And this definite integral is not that difficult to show. We just use the power rule. So let's say I have 1 and then divide by that. So that means I get 1 over e and then x to the power e, and then evaluate this from our bounds from 0 to 1. And then now you can see if I just plug 0 for x, it's just going to be 0. And then if I plug 1 for x, 1 to any exponent, it's always just going to remain 1. And so therefore the conclusion is that this integral is just equal to 1 divided by e, like so. All right then, that's pretty cool if you ask me.